Hi again everybody. In the last video we implemented the neural network and now we simply have to download the data and let the neural network learn. So let's take a look here. We're given a train.csv file. CSV stands for comma separated values. Okay, 28 by 28 pixels. So a total of 784 pixels. Okay, the first column is the actual digit, and then we have the pixels intensities. Okay, so let's download this train.csv. Let me download this shit. What's going on? I have no idea what happened, but my PC froze. Yeah, okay. It could take some time. So anyway, while this is downloading, I have a vector of all inputs and all outputs. Okay, train input and train output. I also want to use a mini batch size, let's say 20. Fair enough. Okay, this is still downloading. Okay, let's copy that. Where am I going? What the fuck? YouTube or something. Okay, rename that train.csv. I think I'll let this start downloading the test data. Wow, it's not completely frozen. I don't know what's going on. Let's try this in a new tab. Anyway, let's take a look at that train.csv file. So yeah, the first row, as usually, is useless. And we have 42,000 of training data. Okay, 42,000. Okay, let's start parsing this. Parse training data. I have a string trash and some if stream in, okay, which we read from train.csv. We first read the first row, which is useless, and then we go on and read all those 42,000 rows. We read that, and then we'll have some vector, I suppose, and then I want to have a matrix for the current input and the current output. The input will of course have one row and 784 columns for the pixels intensities, and the output will have one row and 10 columns, and each column is supposed to store the probability of the current example being a 0 or 1 or 2 and so on up to 9. So I want to have a function which will simply split the data. Okay, split that. And now the output I want to set to 0, and then I want to say output row 0 column v0, which is actually the answer, equals 1. Now I have to take the pixel intensities. So I'll say input row 0 column j minus 1 equals the current pixel intensity, which is vj, and now divide that by 255 so that everything is in the range from 0 to 1. And now I'll say train input dot pushback input and train output dot pushback output. Let's speed things up right now. Train input dot reserve, well, reserve 42,000. Train output dot reserve 42,000. Now the simple split function. We have will be the current number, obviously, and we have something. We gotta have something to return. So let's loop here. If the current character is a comma, then that's the end of the current integer, and we start from 0. Otherwise, it's a digit, so we simply append it. And we also want to add the final, the final number, which will not have a comma after it. So everything seems to be fine. Let's say training data loaded. Yeah. Try to compile that. Also, some function which tells us how much time since the start of the program has been. Okay, how long it has been since the start. Let's try to compile this. All right. It takes around 3 seconds to read the data. Not so good, but anyway. I also want to download the test set. Now let's perform the training. Void train. Since we want to train them, we'll have some epochs. I'll say 10 in the beginning, and I'll see how long an epoch takes. I'm not sure epoch or epoch. Let me just check. Sorry. Okay, epoch. good. Now, first thing we want to do is to random shuffle those inputs, those training inputs, and of course the output. So I'll have a vector with all the indices, I'm sorry, which I'm going to random shuffle, and I don't want to use the built-in random shuffle function. I'm gonna build my own, okay? I think random shuffle is good because we won't use iterators. So we simply swap the current one with something in front of it. So that's good enough. Random shuffle the indices. Now we start looping. And we'll try to form the current mini batch. So let's have a vector of matrices, inputs, outputs, inputs.clear, outputs.clear, now we add the current example, which is train input with this index and the current output example, and it's not j but I plus j. Train output index I plus j. Yeah, fair enough. That's supposed to be good. And then we simply train our network, which we have not defined yet, which was kind of stupid. Let's have a neural network net, which will have, what architecture do we want it to have? The first layer will have 784 neurons, and I'll say let's have 2 hidden layers with 15 and 10 neurons respectively, and then 10 neurons in the end. Or maybe 1 hidden layer should be good enough. And learning rate, I'm gonna use 1. And here net.train inputs outputs. And that's the end of the epoch. And a timestamp, of course, timestamp. Let's see how long 1 epoch takes. I'm going to guess it will be around a minute. I also want to watch out for my random access memory. Okay, so yeah, pretty much around a minute. So I have like 10 epochs, and I also want to be measuring the error rate. So after each epoch, I would like to go through all examples, try to run that network, cur output equals net.feed forward with the current input, train input I, and I'll simply measure this error rate here, just averaging it for everything. Let's go. And then I'll divide the error by 10 and then by 42,000. And say error. Okay. So am I correct here? Let's see. No. Oh, that should not be a vector of matrices. It should be just a matrix. Okay, it compiled now. So the next thing I'd like to do is to test our neural network. I believe this is already downloaded. I'll copy this, paste it here. Now let's take a look. Take a look at this test.csv. So first row is again useless. And then we have some test data. Okay, so I'll probably just parse the test that data in the same way. Test data. Just a moment. Test input. Or maybe I don't even need that. I don't need that. Parse test data. If stream once again test.csv. Now, how many test examples do we have? 28,000. Okay, 28,000. Quite a lot. So let's parse the... No, we don't want to parse the test data. We'll do it on the fly. We'll compute the answers on the fly. So let's again have an if stream, a trash string, some vector, and now we simply go on. 28,000. Read the trash. We split the trash. Have some matrix current input and current output. Current input is gonna have one row and 784 columns. Okay. So current input 0j equals vj divided by 255. Then the current output will become net.feed forward current input. And now we want to have the maximum value, the maximum probability, but it should be double, I'm sorry, and its index, okay? Max value. So the max value is initially -1, let's say, and then we loop through all digits, and if the probability of the image, of the current image being j is greater than max value, then max value equals current output 0j, and the index becomes j. So the answer for this is supposed to be j. Let's see how our output should work. Offstream out ans.csv. Image ID and then label. Okay. Image ID. And then we should print first the index, which is I + 1, a comma, and then the answer. And this should all be good. Let's see if it compiles. I want to see how it measures the error, and then I'll probably stop it and then create another video which will be simply the neural network training itself, and you can follow the progress, and then another video with just submitting the result, the end result. I just want to see the error rate, and I'll stop the video. Come on. Come on. Now the actual measurement of the error slows everything down, but we have patience, we're gonna wait for it. Okay, very nice. First epoch is finished. So I just want to check something once again, one last time. Yeah, we set the error to 0 in the beginning. Then we have 28,000 here. Here we take the max value. Okay, all seems to be good. The next video will be simply the neural network training itself for 10 epochs, and then another one, the last video of this series, where I'll just submit the answer and see what score we can get. See you in the next video.